Over the last few years, systems like GPT-4 and Gemini crossed a threshold that traditional detection cannot reach. They mimic human cadence so perfectly that their writing is now indistinguishable from ours. We are living through an authenticity crisis. Every single email, every news article, or legal brief is now suspect, as no linguistic pattern or stylistic quirk can definitively prove a human being wrote it. To solve this, researchers at the Wharton School have developed a different approach. Instead of analyzing the final text, they embed a hidden mathematical watermark directly into the AI's token selection process. Every time the AI generates a word, this algorithm subtly restricts the options. The resulting sentence contains a mathematically guaranteed fingerprint that survives even if someone heavily edits or paraphrases the output. We now rely on advanced statistics to prove that a human thought actually originated from a human mind. We have reached the point where we can no longer manually verify our own reality. In 1950, Alan Turing asked the question that started this: can machines think? At the time, we assumed that if they could, we would be the ones writing the logic. Following the Dartmouth Conference in 1956, computer scientists built expert systems. The goal was to manually hand-code every logical rule a machine would ever need to understand the physical world. But the physical world is too complex for rigid hand-coded logic. A programmer can write a million if-then rules to identify a cat, and the system will still fail the moment the cat stands behind a chair. Because these early systems were so inflexible, progress stalled. Through the 1970s and late 1980s, the industry hit a hard wall, leading to multiple AI winters, where funding and interest evaporated. These decades proved that as long as programmers insisted on manually steering the machine's logic step by step, artificial intelligence would remain a stagnant experiment. In the 1990s, researchers stopped trying to program rules. Instead, they built neural networks, fed them data, and let the machines discover their own patterns. This shift was accelerated by the internet. By the 2000s and 2010s, we had the massive datasets and the raw computing power required for deep learning, allowing machines to find patterns humans couldn't see. That scaling led to the 2020s and the invention of transformers. Tech companies fed models the entire internet, teaching them to mimic human output and context with near-perfect accuracy. This brings us back to the Wharton watermarking research. Because we no longer write the rules, we have to use mathematical concepts like large deviation theory to catch models that have outgrown our direct control. By teaching machines to learn on their own, we surrendered the steering wheel. We moved from building predictable tools to managing an autonomous mimic. We are now moving beyond generative AI toward a class of systems known as agentic AI. An agent doesn't wait for a prompt. You give it an objective, and it acts, autonomously breaking down goals, using software tools, and deploying sub-agents. These agents observe their results and correct errors in real time, optimizing strategies without human feedback. By 2027, millions of these autonomous bots will operate on behalf of users and companies. They will negotiate and execute tasks directly with one another, effectively bypassing the human attention economy that currently drives the internet. By 2028 and 2029, the economic model based on human wages faces collapse. When machines perform nearly all productive labor, traditional supply chains and national currencies lose their primary anchor. We will see closed-loop, AI-controlled logistics networks. These systems trade resources and computing power at speeds humans cannot process, operating outside traditional banking structures. This transition culminates in 2030. When artificial general intelligence applies expert-level reasoning to every link in the global economy, from fusion energy management to molecular manufacturing, material scarcity begins to fade. With the marginal cost of production dropping toward zero, energy, food, and healthcare become post-scarcity goods. The application of superintelligent reasoning to biology offers the potential to eliminate genetic disorders and radically expand human lifespans. The mathematical watermarks from Act 1 now serve as the foundational laws of physics for this digital reality. They are the only way to govern an infrastructure that has entirely outpaced human manual verification. We are birthing the autonomous, superintelligent infrastructure that will run the post-scarcity future of human civilization.